Alright, welcome back. Now what we're going to do is we're going to start talking about the hyperbola. So the hyperbola, oops, hold on. Oh. Okay, so we're going to do the hyperbola. So we talked about the ellipse before in the last section video. So now we're going to do the next conic section, which is the hyperbola. And we're going to do the graph of the hyperbola at the center, at the origin. Okay, so now we're going to start with the definition. A hyperbola is the set of all points x comma y such that in a plane, points x, y in a plane such that the difference in the distances between the point xy and the foci, which are the fixed points, and the fixed and two fixed points, is a positive constant. Okay, so that is the definition of a parabola. Okay, so the set of all points x comma y in a plane such that the difference in the distances between x comma y, which is a point on the parabola, and two fixed points called foci is a positive constant. So this is very similar to the definition of an ellipse, except we're looking at the difference in the distances being a positive constant instead of the sum of the two distances being a positive constant. So what would this look like? Okay, so this would look like something like this. So I'll draw. So again, we're going to start at the center, the origin. Okay, something like that. Okay, and so we have, one focus over here, right? So we'll call this focus 1, right? So there's focus here, and we'll call this negative c, comma 0. Since this, we're going to say that this is at the origin, right? So that's the origin. So we have a focus here, and we have a vertex here, so this is called the vertex. We'll call it V1. So the vertex is here, okay? And then over here we have another vertex. We'll call that V2, and another focus, F2. And of course, let's take a point here on the hyperbola. So we'll call this x comma y. And we're going to take the distance from the F1, the focus 1. Okay, so we'll call this D1. And then we're going to take that distance, we'll call that D2. And so what we're saying is if we take any point along either the graph of either side, so the graph of the parabola, if we take the distance from one focus to that point and the distance from the other focus to the point, if we take the difference of these two distances, that will always equal a positive constant, no matter where you're at along the line. Now in the next video, I'm going to do the derivation, and the derivation is going to be very similar to what I did with the ellipse. So I'm going to assume if this is true for any point along the hyperbola, then it'll be true if we're right on the x-axis. So that's where I'm going to start. I'm going to find out what that constant is by doing that, and then I'll do what I did the same thing, is I'll generalize it as, since I now can, I'll have the distance, what that constant is, right? And just like I did before, and then once I know what that constant is, then I can go back to the beginning and derive the formula for any point on the hyperbola, on the graph of the hyperbola. Okay? Okay, so that's what we're going to do in the next video, is derive the formula for the equation of a hyperbola that's centered at the origin.